Before I start, I'd like to just say a few words about the co-authors of the paper that was written that initiated this presentation. This was originally, as Patrick mentioned, there were supposed to be co-presenters here today. Unfortunately, one of them couldn't make it for personal reasons. Paul Staneri, he's an engineer in our Worldwide Engineering Center, and he's in our dispatch and human interface section in the Otis Engineering Center. A couple of other people that also contributed to the paper that led to this presentation. Gita Bora, who is a senior technology manager in our Building and Industrial Systems Division of United Technologies, and also Arthur Su, who's here today, is an engineer with our System Dynamics and Optimization group at the United Technologies Research Center. So there were 4 people that contributed to this, and I'm the sole presenter today. I have a lot of material to get through. Hopefully we'll have time. Not a lot of graphics, a lot of information, printed information, because I'm going to be reviewing safety codes and research. So bear with me if I read a little bit at a time, because I want to make sure I get the information correct. We're all hearing a little bit more, or a lot more these days, about intelligent buildings. And intelligent buildings obviously need intelligent systems inside them. So I'm going to talk about some of the systems in buildings today, not only elevators, but the systems that can connect to elevators, like the fire alarms, the security systems, HVAC, and emergency power. Before I get into the integration of those systems, and by the way, I think I forgot to mention that my topic is evacuation of buildings using elevators. I'm going to review what's been published in the North American Elevator Code, the A171B44 Safety Code. There's a new operation in there called Occupant Evacuation Operation that I was deeply involved with over the 10 years it took to develop and write it and get it put into the code. So I'm going to talk a little bit about that, and then I'll move on to the concept I first alluded to about integration of building systems and some other opportunities for improving the evacuation system using an objective-based approach. And that'll be accomplished by introducing some new hardware, some new terms. First of all, the Evacuation Controller, which is kind of the mastermind of this integrated system, and the Content Server and Command Center, which are also integrated into the system, and I'll explain what they do. There's been a lot of research into evacuation of buildings using elevators, some of it going back 10 years or more, including from this particular conference in the past, and some of the people doing papers and presentations at these conferences. And the general thrust of that research and those papers has been that the use of elevators can improve the evacuation time beyond what you can attain with stairs alone. Now, getting into occupant evacuation operation and its development, there was a workshop held in Atlanta, in the U.S., in 2004. It was organized by the American Society of Mechanical Engineers, although there were a number of other organizations involved, code writing organizations such as ICC and NFPA. They write the building codes and life safety codes and so on, and also the U.S. Access Board, the International Association of Firefighters, and NIST, the National Institute of Science and Technology. So there was a lot of involvement from the code writing community and the accessibility community in this workshop. And at this workshop, 2 task groups were established. One was to look at use of elevators by firefighters, and the other was to look at use of elevators for occupant egress. And I ended up chairing both of those task groups. And what the task group did after the workshop was commence the process to review all of the suggestions that came out of the workshop and from the various breakout sessions, develop a prioritized list of those issues, and then conduct a hazard analysis of the prioritized list. And from the hazard analysis, they would take the corrective actions that were developed during the hazard analysis, and from there develop either code recommendations or actual language that could be proposed to the code committees. And these were all sorted by the various types, primarily elevator, but there were also many building code proposals that came out of it, life safety, electrical, and also training recommendations for firefighters, and also we addressed accessibility issues. Excuse me, it's hot and dry under these lights. Now, the hazard analysis process that we followed specifically was an investigation of the use of elevators during emergencies for evacuation of occupants in an occupied high-rise office building prior to the activation of firefighters' emergency operation Phase 1 recall. I hope everyone's familiar with what we call Phase 1. That's when all of the buildings are recalled from the upper parts of the building down to the main floor whenever a fire alarm initiating device is activated. So the task group came up with a new operation. We had firefighters emergency operation. Now we're going to have occupant evacuation operation. And this is the operation of an elevator system for occupant evacuation under emergency conditions. The way it works is the fire alarm system provides signals to the elevator system indicating the floors to be evacuated. And then there's egress from what we call the 5 affected floors. And that's the fire alarm floor, 2 above and 2 below. This system is not mandatory. It's a voluntary requirement. But if you do it the way it's written, is the way you have to implement it. Now, it's also got provision for going to what we call a full building evacuation, or the zone of 5 floors can be expanded to as many floors as necessary. So if you have a second alarm, you would expand the zone from the lowest alarm from the lowest alarm floor to the highest alarm floor, all floors in between, plus 2 floors above the highest and 2 floors above or below the lowest. And it also can be initiated manually by emergency personnel. Now, what critical part of the system is what we're calling real-time signage. There's real-time signage and voice announcements that must go along with this system to instruct occupants on how to evacuate. Because this is a whole new paradigm for building occupants. Previously they've been told not to use the elevators when there's an emergency. So there are no actual messages that are specified in the code. These are samples or examples. The samples are given in the code, but they're not mandatory. The elevator designer or the building designer is free to develop the messages that they need for their particular building. But there would be signage at every floor, in the elevator lobby, in every elevator car, and of course at the main floor to tell people not to enter the elevators. Now, many of you may have seen this sign before. I noticed that something similar to this sign is on the floors here in this hotel, and it's been around for many years. And this is what people are used to seeing: don't use the elevators when there's an emergency. This kind of sign, of course, will not be used in a building that has occupant evacuation operation. We'll have what we call the real-time signage, And we'll also have accompanying real-time voice announcements for the lobbies and the cars. So specifically then, what happens when occupant evacuation operation is activated? All of the landing calls are canceled and disabled. All the security systems are overridden. Only the landing calls within the affected floors will call an elevator. The floor with the active alarm is given the highest priority. At other floors, within the 5, evacuation priority is assigned in the sequence received. The highest calls are given the highest priority in a full building evacuation situation unless there are calls at affected floors. They always retain the priority. And car calls are disabled except for the elevator discharge level or likely the main level. Unoccupied elevators would move to a floor being evacuated and park with the doors closed until a landing call is registered. Occupied cars would proceed directly to the elevator discharge level, then proceed directly to a floor being evacuated. New landing calls would be registered immediately and assigned to another car, and any new landing calls would not prevent a loaded car from leaving. Cars that are 80% loaded would be instructed to leave the floor, close the doors, and proceed to the discharge level. But if somehow they do become overloaded, they will not leave, and you'll get a message telling people to get off the car. The doors will stay open until you're back down to the 80% level. So once you have evacuated a floor, you'll, of course, start to have no landing calls because the people are gone. However, we do want to recognize that there may be stragglers. So if there's a 60-second period in which no landing calls have been received, then the cars will start to evacuate the next level. One car would park with its doors closed at the lowest level of the affected floors, ready to answer a call from say, a straggler. And the rest of the cars, if the evacuation is done, the rest of the cars will park at the elevator discharge level. Now, with firefighters' emergency operation, that system has always worked on a particular group of elevators. Now we've added the ability for firefighters to recall one car at a time. So they have a choice of the whole group, or they can recall one car. They can use 1 or 2 cars for firefighting duties and leave the rest of the cars still operating in occupant evacuation operation. And occupant evacuation operation will be terminated if there's a reset of the fire alarm system or any smoke detector, any fire alarm initiating device or key switch is initiated or activated, which would normally initiate firefighters' emergency operation phase 1 recall. And all of the keys have to be the same for both systems, for OEO and FEO. Now, along with the code requirements, we've also published in the code an appendix on the building requirements that are considered necessary to go along with OEO. And these are in an appendix because the elevator code can't specify what's required in the building. But it does list these assumptions or requirements that are considered recommendations. So first of all, it explains that the occupancy is a high-rise type complying with the building code, that there are protected lobbies provided that'll shelter 25% of the floor population, and that there are stairwells with direct access to those protected lobbies. The hoistways, lobbies, and stairwells are pressurized. There's an automatic sprinkler system complying with the sprinkler code, except that there are no sprinklers in the machine rooms or hoistways. There's a building smoke detection system, a voice and alarm system according to the fire alarm code. protected emergency power, and it needs to be operational for 2 hours for not only the elevators, but the signage and voice systems, the pressurization systems, and the ventilation. And the hoistways need to be protected from water flow that could be caused by sprinklers. That again is not specified how that should be done, but there are examples given such as sloping the floors or providing drains in the lobby areas. The other thing that's critical to this is there must be a building fire and evacuation plan, and that plan needs to include procedures for evacuation using both stairs and elevators. It needs to include building occupant training and drills. It should consider the use of floor wardens to direct people, and also there should be routine testing of the entire system. So these requirements were published in the 2013 edition of the A171B44 North American Elevator Code, and there are complementary requirements in the building code, the IBC, and the NFPA 5000, and the NFPA Life Safety Code. By the time the next edition of the building codes are published in 2016, there will be basically full integration between the elevator code and the building codes, so they'll be aligned, which they have not been for many years in this respect. Okay, so I'd like to move on now and talk about alternative strategies, which I mentioned initially. Again, I mentioned studies that have been done going back 10 years or more, and these studies have concluded that use of both the stairs and elevators during emergencies is a preferred method to reduce egress time. Current standards follow a rule-based protocol. That's what I've just been through, all of those rules. Even though it's not mandatory, if you do it, you have to do it that way. And those rules were written with the goal of reducing evacuation time. But there may be an alternative way to look at it using an objective-based approach that looks through different alternatives and prioritizes the floors served by the elevators based on risk measurement, and not just evacuation time. So you can use information from the various building systems to alter that objective-based approach continuously. You could look at people flow, the spread of the fire, any smoke or other threats to update the approach. And your communications, again, would be critical. Signage, voice signage, and electronic signage, and transmission even to mobile devices so that you could actively guide building occupants to follow the best egress path. And you can also combine first responder needs with this system. So we've done some analysis. We looked at a model which looked at the 3 different approaches, simply the pedestrian flow model down a set of stairs, the elevator model, which would look at occupant evacuation operation, and then a third model which compares the third approach. The model consisted of a hypothetical 47-story building, 24 elevators, and 2 stairways. And there's a threat on the 45th floor. The 24 elevators all access the ground floor, and they're divided into a low-rise, mid-rise, and high-rise group. And what we've done is assign the risk measure per occupant at the threat floor to be 50 times greater than non-threat floors and 25 times greater at the 2 floors above and below the threatened floor, the 45th floor. And then the strategies were compared with the goal of minimizing both the risk exposure and the evacuation time. The exact risk exposure is computed by the time spent at each floor in the building, multiplied by the risk measure at the floor, summed for the last evacuee from each floor. So if you're using the occupant evacuation operation approach, it'll sequentially evacuate the floor population to the ground floor with these priorities. Floor 45 is the fire floor. Then it does the 2 floors above and the 2 floors below. And the total evacuation time computed was 28 minutes with a risk exposure of 1352. If you look at stair-only evacuation, the simulation evacuation time was 84 minutes with a risk exposure of 2003. So that's 3 times longer than using OEO. And then if you looked at the objective-based approach, you move occupants away from the high-risk floors, which are 45 to 47, to a low-risk floor. The elevator shuttle occupants from the low-risk floors to the discharge level. Occupants on floors 12 and below are instructed to use the stairs. Occupants on floors 14 to 23 are instructed to take the stairs to floor 13, where they will be shuttled to the discharge level. And if you need to make exceptions for occupants who cannot use the stairs, you can factor that in as well. So this approach balances the use of stairs and elevators, and the simulated evacuation time was 24 minutes with a risk exposure of 777. So there's a comparison of the 3 approaches. This objective-based approach is obviously a faster evacuation with a lower risk in total to the occupants. Now, I mentioned the integration of intelligent systems, and this flow chart shows the connection of those systems. At the beginning of the presentation, I mentioned this evacuation controller and also the content server and the command center. So these are the 3 new devices that need to be added into this integrated building system. And then the other systems are the systems that we've had for many years. Of course, the elevator system, HVAC, fire alarms, and so on. So just to explain what the evacuation controller would do, it coordinates the response of building systems. It needs to be redundant to have a high level of reliability and availability. In the fire scenario, it obtains information from the various systems and utilizes those different systems to evacuate the building using the objective-based approach. It tracks the threat and using the information from the content server. So the content server then can modify exit signage and provide voice notification to control the floors the elevators will evacuate, to adjust the HVAC system, to control smoke and provide pressurization, and provide information to the command center to aid first responders. We could use video to monitor queuing, wait times, and flow monitoring and wrong way detection. And this information then allows the evacuation controller to optimize the performance of the system in real time. The content server is directed by the evacuation controller, and it delivers the audio and visual messages. It can also deliver the messages to mobile systems. It's a mass notification and emergency communications system, and can provide wayfinding in the form of signs, maps, and other graphical or audible information. The command center provides decision support and control for first responders. It's a central monitoring station for the alarms and could allow remote access and redundancy, improving the reliability and providing scalability, and could allow remote monitoring from outside of the building. Of course, emergency power is critical. All of these systems need to be available at all times and reliable. So everything's backed up with emergency standby power. So I want to mention one other thing in conclusion. This chart just summarizes what I've been talking about, but I think an important thing that I haven't mentioned yet is the human factors considerations and situation awareness. Until we actually get an emergency, we don't know how people are going to react. And so it's critical to have the correct signage. It's critical to have the right messaging to the people. And without that, none of these systems are going to work. It'll be chaos, especially in the early stages when these new systems are introduced. So with that, I'll wrap it up. I see my time is up. Thank you very much.